Hello students, welcome to another lecture of the topic electrostatics. In today's lecture, we are going to discuss regarding the combination of capacitors. जसं आपण 10वी मध्ये combination of resistances शिकलो होतो, resistances in series and resistances in parallel. अगदी तसंच आता आपल्याला शिकायचं आहे combination of capacitors. Combination of capacitors. एक combination क्या रहेगा? Capacitors in series. तर पहिला पॉइंट आपण काय घेणार आहोत? series combination, series arrangement. Okay, now what happens in series combination? Suppose if I take the number of capacitors having capacitance is C1, C2 and C3 and they are connected as shown in the diagram. Diagram मध्ये तुम्हाला clearly दिसते. Okay, the first plate of the capacitor will be connected to the positive terminal of the cell, and the second plate of the last capacitor will be connected to the negative terminal of the cell. The second plate of the first is connected to the first of the second. Second of the second is connected to the first of the third, and so on. आता इथे आपण फक्त तीनच कॅपॅसिटर्स घेतलेले आहेत. ओके, आता नीट पाहून घ्या की हाऊ द थिंग्स हॅपन. Now, first and most important thing, when you are connecting the capacitors to the DC source, the current flows till the capacitors are charged. Once the capacitors are fully charged to their capacity, the flow of current stops. So, when a current flows, this first plate will get the charge, say plus Q. And this positive charge will induce a negative charge on the second plate of the first capacitor. हा काय असणार आहे? Induced charge. So किती असणार आहे? minus Q. The induced charge on the far side of the C1 will go to C2. म्हणजे C2 च्या प्लेटवर पण चार्ज काय असणार आहे? प्लस Q. हा प्लस Q या सेकंड प्लेटवर चार्ज इंड्यूस करतो, काय असणार आहे? मायनस Q. आणि ह्या बाजूला जो पॉझिटिव्ह चार्ज इंड्यूस झालेला आहे that will go over here, and here also will have charge plus Q. This plus Q will induce a negative charge on the near side and positive charge on the far side. Positive charge comes over here. The circuit is complete. Once the capacitors are charged, the flow of current stops. The flow only takes place till the capacitors are being charged. When you are connecting the capacitors in series, the charge on each capacitor is same. However, the potential difference across the plates of the C1, say let it be V1, the potential difference across the plate C2, say be V2, and potential difference across the plates of capacitance C3 be V3. This values V1, V2 and V3 will be different and will depend upon the capacitance. हाँ, अगर capacitance same रहे, C1 is equal to C2 is equal to C3, then V1 is equal to V2 is equal to V3. The potential difference across each capacitor is different, and this V1 plus V2 plus V3, this V1 plus V2 plus V3 is equal to V. V is what? This total potential difference. So what does capital V stands for? The capital V stands for the potential difference across the entire combination. Okay. अब यहां पर देखो, ये जो तीन कैपेसिटर्स हैं C1, C2 and C3, I will draw an analogous circuit over here. अजून एक सर्किट तुम्हाला इक्विवेलेंट सर्किट दाखवतो. एक ही कैपेसिटर लिया है मैंने, एक ही कैपेसिटर लिया है, सेम सोर्स ऑफ ईएमएफ कनेक्ट केलेलं आहे मी, और ये एक अकेला है. and the potential difference across the plates of this akela capacitor is V. So what is this C? This C, which has the same potential difference across its plate as equal to the sum of the potential difference across these three capacitors, this C is called as equivalent capacitance of C1, C2 and C3. What is this C called as? Equivalent capacitor. या सर्किटला आपण सिंपल सर्किट केलेला आहे. Instead of all these three capacitors, I am drawing only one capacitor. That single capacitor whose effect is same as that of the combined effect of these three capacitors is called as what? Equivalent capacitance. What is the potential difference across the plate of this capacitor of equivalent capacitance? V. Okay. अब हमने क्या सीखा था? Q is equal to CV. What is V is equal to Q upon C. Okay. ध्यान से देखो यहां पर इस बैटरी से जो करंट फ्लो होगा वो इसमें चार्ज इंड्यूस करेगा, से प्लस क्यू, यहां आएगा माइनस क्यू एंड द पॉजिटिव विल कम ओवर हियर एंड द सर्किट इज कंप्लीटेड. द करंट विल स्टॉप वंस दिस कैपेसिटर इज व्हाट? चार्ज्ड. ओके. यानी the charge on this capacitor whose capacitance is equal to the equivalent capacitance of this combination is also what? Q. आता हा फॉर्मूला बघा तुम्ही, V is equal to what? Q upon C. तर V के प्लेस पे क्या लिख रहा हूं मैं? Q upon C. V1 के प्लेस पे क्या लिखूंगा मैं? Q1 upon C1. V2 के प्लेस पे क्या लिखूंगा मैं? Q2 upon C2. V3 के प्लेस पे क्या लिखूंगा मैं? Q3 upon C3. But note one thing, what? Q is equal to Q1 is equal to Q2 is equal to what? Q3, and therefore I can write what? 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. That means when the number of capacitors are connected in series, the reciprocal of equivalent capacitance is equal to the sum of the reciprocals of individual capacitance. आता तुम्हाला तीनच कॅपॅसिटर दिले, समजा चार असलेस तर मी काय लिहिलं असतं? 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 and so on. अगर n कंडेंसर्स रहेंगे, n कैपेसिटर्स रहेंगे तो मैं क्या लिखूंगा? 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon CN. Got it? So in case when the capacitors are connected in series, the reciprocal of equivalent capacitance is equal to the sum of reciprocals of the individual capacitance. When capacitors are connected in series, the charge on each capacitor is what? Same. The potential difference across the plates of each capacitors is different and it depends upon what? Its capacity. अगर तीनों capacitance के capacity equal रहेंगे, then the potential difference across each plate will be also what? Different. And if it is same, then potential difference V1 will be equal to V2 will be equal to V3. The sum of the individual potential difference across the plates of each capacitor is equal to the total potential difference across the combination. Equivalent capacitance क्या होता है? वो capacitance whose a single capacitor whose effect is same as that of the combined effect of other capacitors. Okay, now you can pause the video, take a screenshot of this and write in your notebook. Let's start with the next part, that is when the capacitors are connected in parallel. Now what happens in a parallel combination? Each plate, first plate of the capacitor is connected to the positive terminal and the second plate is connected to what? Negative terminal. Now I am connecting these three capacitors as shown in the diagram to a source of EMF. Now there is no charge on this capacitor. This source delivers current. What is current? Rate of flow of charges. So charges are flowing over here. When charges come over here, they will be split up into three branches. Some charge will flow over here, some will go over here, some will go over here. अब कितना चार्ज कौन से ब्रांच में से जाएगा, that depends upon what are the capacitance of the capacitors in their respective branches. अब यहाँ पर जो चार्ज आया, that will be deposited over here. Say let it be Q1, okay, and that induces the negative charge on the near side and positive charge on the far side that comes over here. यहां से चार्ज आया और इस प्लेट पे आया चार्ज प्लस Q2, that will induce a negative charge over here, say minus Q2. The positive charge induced over here will go through this branch and will come over here. Now the charges that are going to come over here, flow over here, will be deposited on this plate. Let it be Q3. This charges that are deposited will induce a negative charge on the near side and the positive charge on the far side, which will go over here. यहाँ से Q1 आएगा, यहाँ से Q2 आएगा, यहाँ से Q3 आएगा. यहाँ पर कितना आया? Q1 plus Q2 plus Q3. वही चार्ज इधर जाएंगे. यहाँ से कितने आए थे? Q1 plus Q2 plus Q3. वापस कितने जा रहे हैं? Q1 plus Q2 plus Q3. Okay. Now this flow will continue till when? ये flow कब तक continue होगा? This flow will continue till the capacitors are charged. Remember one thing, I am repeating this many times, that once the capacitors are charged, then there is no flow of current. In a steady state, the battery doesn't deliver any current. Okay. Now the capacitors will have each capacitors will have different charges depending upon their capacities. But as the positive plate of each capacitor and negative plate of each capacitor are connected to the common points, the positive plate of each capacitor is connected to this point, say A, and the negative plate of each capacitor is connected to this point, say B. That means potential difference across each plate, so potential difference across the plates of each capacitor will be same and is equal to applied potential difference V. Now this diagram can be equivalent diagram. ऐसा हम ड्रॉ करेंगे. एक इंडिविजुअल कैपेसिटर लेंगे, ये सोर्स ऑफ ईएमएफ रहा, ये C रहा, ये पोटेंशियल V रहा. इस डायग्राम में चार्ज कितने फ्लो हुए थे? Q1 plus Q2 plus Q3. तो इस पे चार्ज कितना स्टोर होगा? वो होगा Q1 plus Q2 plus Q3 will be stored on this. Obviously minus Q1 minus Q2 minus Q3 will be induced on this, plus Q1 plus Q2 plus Q3 will be induced on the far side, and that will go to the negative terminal. Once the capacitor is fully charged, there is no flow of the current. Now what is that? C is a capacity of an equivalent capacitance of this three combination. Yani what is an equivalent capacitor? It is a single capacitor on whom the charge stored is equal to the sum of the charges stored on individual capacitor, and the potential difference across their plate is same as that of what? Applied voltage. वो इक्विवेलेंट कैपेसिटेंस C और ये C1, C2 और C3, ये इनमें कॉमन क्या है? पोटेंशियल डिफरेंस. इस पे चार्ज Q1, इस पर चार्ज Q2, इस पर चार्ज Q3 है. इक्विवेलेंट कैपेसिटर पर चार्ज कितना है? Q1 प्लस Q2 प्लस Q3. क्या मैं ऐसा लिखूं? अगर इसको मैं बोलता हूं लेट द नेट चार्ज ऑन दिस be Q, then what I will write over here? What is Q is equal to? Q1 plus Q2 plus Q3. But what is Q is equal to? CV. What is Q1? C1 V1. What is Q2? C2 V2. What is Q3? C3 V3, but what? V is equal to V1 plus V2 plus V1 is equal to V2 is equal to V3. The potential difference across each capacitor is what? Same. तो V1, V2 और V3 क्या हो जाएंगे? कैंसिल हो जाएंगे. तो C क्या आया? C1 plus C2 plus C3. So when the capacitors are connected in parallel, the equivalent capacitance is equal to the sum of individual capacitance. Resistance in series and resistance in parallel चे result अगदी ह्याच्या उलटे होते. See, remember this thing in your mind. What happens when you are solving the problems for resistances, combination of resistances, and problems on the combination of capacitor? Have one thing in your mind. When resistances are connected in series, what is Rs is equal to R1 plus R2 plus R3. What is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. However, what happens in a capacitor? When capacitors are connected in series, 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. And when they are connected in parallel, say when n capacitors are connected in parallel, the equivalent capacitance will be given by Cp is equal to C1 plus C2 plus C3 plus till Cn. यानी अगर मुझे कैपेसिटेंस बढ़ाना है तो मैं कैपेसिटर्स को पैरेलल में कनेक्ट करूंगा या सीरीज में? आई विल कनेक्ट देम इन व्हाट? I will connect them in parallel. Cp is equal to C1 plus C2 plus C3 plus dot 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 Cn. Very important relations. Mostly in the your entrance examination, the problems are asked on the combination, series combination and parallel combination. So we will discuss about the problems also on this. But I would like you to take a note of this. Pause your video, take a screenshot. If possible, write down in your notebook right now. Let us solve some simple problems on the combination of the capacitors. Now the question is find equivalent capacitance between A and B when two capacitors of capacitance 6C and 12C are connected in series. Okay. Now these two are connected in what? Series. Series के लिए formula क्या है? 1 upon Cs is equal to 1 upon C1 plus 1 upon C2. 1 upon Cs will be equal to 1 upon 6 plus 1 upon 12. 1 upon Cs will be equal to 12 LCM. So you have 2 plus 1, that is 3 upon 12, which is equal to 1 upon 4. So what is Cs is equal to 4C. है ना? इधर मी फक्त इधर 6 आणि 12 लिहिले. इथं ऍक्च्युअली काय असणार आहे? 6C आणि 12C. बरोबर? मग 12C तुमचा LCM येणार आणि मग हे येणार 4C. तर तुमचा आन्सर किती आला सांगा मला? 4C. बट note one thing, whenever the capacitors are connected, two capacitors are connected in series, the best way is take their product upon addition. So you reach to the answer very quickly. अब यहाँ पर नंबर क्या है? 6 और 12. 12 और 6 का प्रोडक्ट कितना हो गया? 72. 6 plus 12 कितना लगा? 18. What is 72 upon 18? 4. Your answer is what? 4. When there are only two capacitors connected in series, to find out the equivalent capacitance, divide the product by the addition. Okay? Now look at this particular second problem. Now I am expecting the second problem you solve it very quickly. Now the question is find equivalent capacitance between A and B. Find equivalent capacitance between A and B. If you look at the diagram, 3C and 6C are connected in series. 9C and 18C, they are connected in series. तो इसका जो नेक्स्ट स्टेप आएगा, अभी मैंने आपको एक सिंपल मेथड बताया था कि when only two capacitors are connected in series, divide the product by its sum. तो यहां पर नंबर क्या है? 3 और 6. 3 और 6 का प्रोडक्ट कितना है 18, एडिशन कितना है 9, 18/9 कितना 2, तो यहां पर क्या आएगा बोलो मुझे, इसका इक्विवेलेंट आएगा 2c. Am I right? Okay. Now what you have number over here 9 and 18. Okay. Now what you are going to do? You are going to take their product divided by what? Addition. Am I right? 9 and 18 है, अभी प्रोडक्ट गया 9 plus 18 कितना है 27, 1 जा 3 जा 1 जा 6 जा, तो ये कितना है 6c. Okay. Now if we look at the diagram, it's very clear that 2c and 6c, they are connected in parallel. When 2c and 6c are connected in parallel, how to get to their answer very quickly? अगर पैरेलल में कनेक्ट है तो हम सिंपल ऐड करेंगे. What is 2 plus 6 is equal to 8. So your answer is what? 8c. In the first question the answer is what? 4c. In the second question the answer is what? 8c. We are starting with the simple problems. Remember one thing, when two capacitors are connected in series, equivalent capacitance find out करने के लिए सबसे fast मेथड क्या है? Divide the product by its sum. Got it? Please write down this in your notebook. Moving on to the next problem. Find equivalent capacitance between A and B. ये दिया 8C और ये 4C. Okay. Now how to solve such problems? The first thing, these three capacitors are in series and these two are in parallel. Whenever the capacitors are connected in parallel, it's very easy to find their equivalent capacitance. Their equivalent capacitance can be easily found by what? Adding them. You have 8C and 4C, you have what? 12C. So this is A and B. This parallel combination, these two capacitors are replaced by a capacitor of equivalent capacitance. If it is parallel, directly add them. Now 8, 12, 24 and 12, these four capacitors are connected in series, and the formula for equivalent capacitance is 1/Cs is equal to 1/C1 plus 1/C2 plus 1/C3 plus 1/C4. The reciprocal of equivalent capacitance is equal to sum of the reciprocal of individual capacitance. 1/Cs is equal to 1/8. Now I am not writing the C each time over here. At the end of the answer we will take it 1/12 plus 1/24 plus 1/12. Therefore 1/Cs is equal to 8, 12, 24 and 12. The LCM is what? 24. 3 plus 2 plus 1 plus 2, 3, 5, 8, 8 by 24, and that is equal to 1 by 3. 1/Cs is equal to 1/3. So what is Cs is equal to 3. Don't forget to write what? C. So what is your answer equal to? 3C. Cs is equal to 3C. Now suppose if this question comes in your CET examination or has been asked in MCQ in your board examination, you need to solve this very quickly. 8 और 4, 12 यहाँ तक तो easily आ जाता है. मैंने हमेशा कहा कि whenever the capacitors are connected in series, you take their product, take their sum and divide product by sum. 24 into 12 upon 24 plus 12 is 8. 8 and 8 will become what? 4. 4 and 12. 4 into 12, 48. 4 plus 12, 16. 48 upon 16, 3. If you have got the way I have solved the problem orally, it's okay. You can solve it even in this way. Okay? एक आदत डालनी पड़ेगी अपने को कि प्रॉब्लम देखने के बाद ओरली कैसे सॉल्व करते हैं. देखो वापस से देखो. ओके 8 and 4 12, 12 and 24. क्या बोला था मैंने? प्रोडक्ट अपॉन एडिशन. 24 into 12 डिवाइडेड बाय 36. तो आंसर हो गया 8. 8 और 8 ये क्या हो गया? 4. 4 और 12, 4 और 12 यानी प्रोडक्ट कितना? 48, एडिशन कितना? 16. 48 upon 16, 3. If you have got the way how I have solved the problem orally, it's okay. If not, it's still okay. You can solve by this method. Okay, please note down this problem in your. Moving on to the next question. The question remains same, find equivalent capacitance between A and B. You have the capacitors arrangement as shown in the diagram. Now as soon as you see this diagram, the first thing you look at this part, that these two capacitors, one of 6C and other of 3C, they are connected in what? Series. ये दोनों इसमें connected है, series में connected. Okay. The second plate of the 6C is connected to the first plate of what? 3C. These two are in what? Series. Now how to find the series equivalent capacitance in series combination? Product upon what? Addition. तो इनका प्रोडक्ट कितना है? 6 और 3 का प्रोडक्ट कितना है? 18. ओके, एडिशन कितना है? 6 और 3 का 9. व्हाट इज 18 upon 9? 2. So what is this? Equivalent capacitance is equal to 2. And now my diagram will be in this way. Instead of this 6 and 3, I'll be taking what now? 2C. And other all capacitors I am retaining as it is. यहाँ पर कितना है? 6C. यहाँ पर कितना है मेरा? 24C. यहाँ पर कितना है? 8C. Okay. Now this 2C and 6C, they are connected in what? Parallel. And when the capacitors are connected in parallel, how to find the equivalent capacitance? Directly add them. 2 plus 6, 8. So this diagram will become in this way. This 24C, then I have 8C, and then again I have what? 8C. 24C. A and B. Now all these three capacitors are connected in what? Series. And what is 1 upon CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. 1 upon CS is equal to 24, 8, 8. LCM कितना हो गया? 24C. ये आएगा 1, 3. ये कितना आएगा? 3. So what is this equal to? 6 and 1, 7. 24C. The what is equivalent capacitance equal to? 24C upon 7. So your answer is what? 24C upon 7. Got it? This is the way how you can solve this problem. ध्यान से देखो अभी यहाँ पर, अगर एग्जामिनेशन में आता तो मैं ये ओरली भी कैसे कर लेता. देखो 6 और 3 क्या है? सीरीज. एडिशन प्रोडक्ट कितना है? 18. एडिशन कितना है? 9. 18 upon 9, 2. 2 और 6 क्या हो गए? पैरेलल में. 2 plus 6, 8. ओके. 24, 8, 8. 8 और 8 कितने हो गए? 4. 4 और 24. प्रोडक्ट अपॉन एडिशन. 24 into 4, 96. 24 plus 4, 28. 96 upon what? 28. Both are going in 4 stable. 24 upon what? 7. And that is your answer. CS is equal to 24C upon 7. If you are able to do it orally, it's good. If you are not able to do it orally, then do it in a step by step manner, but get the right answer. Okay, let's take a note of this one. Let's take the next problem. Okay, the question remains same, find equivalent capacitance between A and B. Now one very important point that you must note, that if n capacitors of equal capacitance C are connected in, अगर सीरीज है और अगर पैरेलल है. अगर सीरीज है तो इक्विवेलेंट कैपेसिटेंस सीरीज के लिए आएगा C upon N और पैरेलल क्या आएगा? N into C. If I have say 4 capacitors, each of 10, 10, 10, 10 microfarad, and if I am connecting them in parallel, then what will be the answer? 4 into 10. The answer will be what? 40. If I am connecting them in what? Series, so answer क्या आएगा? 10 upon 4, यानी कितना? 2.5 microfarad. Remember this. If n capacitors of equal capacitance C are connected in series, then equivalent capacitance is C upon n. If they are connected in parallel, it is what? NC. Now in your CD examination, once the question was asked in this way, n capacitors of equal capacitance are first connected in series, then in parallel. Then the ratio of the equivalent capacitance in series combination and in parallel combination is, for series combination it is what? C upon n. For parallel combination it is what? N into C. They asked us what? The ratio. So ratio कितना आएगा? C upon n divided by NC. Cc will go off the board. 1 upon n into n. The answer is what? 1 upon n square. Now why I have taught this particular part before solving this one? Look at this. We will try to solve this problem. We will figure out this problem without drawing any extra network now. Okay, पूरा tree diagram draw करने का नहीं. 9, 9, 9. They are connected in what? Series. If 9, 9, 9 they are connected in series, then your equivalent capacitance will be equal to what? 3. Why? 9 upon 3. Okay. 3 and 3 they are connected in what? Parallel. 3 और 3 parallel में, तो addition कितना हो गया? 6. 6, 6 और 6 they are connected in what? Series. Then the equivalent capacitance will be what? 2. 2 and 2 they are connected in what? Parallel. तो आंसर कितना आएगा? 4. और लास्ट को 4, 4 और 2 they are connected in what? 4, 4 and 2 they are connected in series. So आपका आंसर आएगा 1 upon 4c plus 1 upon 4c plus 1 upon 2c. LCM आएगा 4c. 1 plus 1 plus 2 ये आएगा 4 upon 4c. So C equivalent will be equal to what? C. Have you got this? I will repeat it. 9, 9, 9 they are connected in series, so and equivalent capacitance is 3C. 3C and 3C they are connected in what? Parallel. Answer is 6C. 6C, 6C, 6C they are connected in what? Series. Answer is what? 2C. 2C and 2C they are connected in what? Parallel. Answer is what? 4C. 4, 4 and 2 they are connected in what? Series. Then the formula for equivalent capacitance is as shown over here. ध्यान से देखो, ये आंसर इधर कितना आया था? 4. 4 और 4 कितने हो गए? 2. 2 और 2 कितने हो जाएंगे? 1. Your answer is what? C equivalent is equal to C. Okay. If you have not understood, just rewind the video and once again try to understand what I have tried to explain. And please take a note of this. In our next lecture, we will solve the problems which are little but of an higher order difficulty level. We are also going to discuss when a dielectric slab is introduced between the plates of the capacitor, what will happen. We will even discuss when a dielectric plate, which is not of the width equal to the separation between the plates of the capacitor, is introduced. So more interesting problems in our next session. Thank you.